This is Bob. Bob has a hearing problem, and it's up to us to figure out what's going on. There are two important hearing losses to consider. Sensory neural, which means there's something wrong with the auditory nerve or the cochlea, and conductive hearing loss, when there's a problem with sound passing to the inner ear. We can use two tuning fork tests called Weber's and Rinne's tests in order to figure out what's going on. First up, we'll need a 512 Hz tuning fork, and we're going to start with Weber's test, but it doesn't really matter which one you start with. We strike the tuning fork so it starts vibrating, and then we're going to place it in the middle of Bob's forehead. We're going to ask him which side the sound is loudest. Now normally, the sound should be equal in both ears. However, if there is an abnormality in any of the ears, the sound will lateralize. This can mean one of two things. Either there is a conductive hearing loss in the ipsilateral ear, or there's a sensory neural hearing loss in the contralateral ear. Ipsilateral just means the same, and contralateral means the other. Now we can move on to the Rinne's test. We need to strike the tuning fork and hold it on Bob's mastoid process. We need to ask him if he can hear the sound and then to tell us when he can't hear it anymore. This will measure bone conduction. Once he stops hearing the sound through the mastoid process, we need to move the tuning fork right next to his ear. This will measure air conduction. In a normal situation, Bob will say that the sound was louder when the tuning fork was next to his ear than when it was on the mastoid process. Rinne's terminology is a bit different. A normal test, i.e. where air conduction is louder than bone conduction, is known as a Rinne's positive test. An abnormal test, on the other hand, where bone conduction is louder than air conduction, is known as a Rinne's negative test. So let's put the two together. We know when we did the Weber's test, Bob said it was lateralizing to this ear. That means either that ear has a conductive hearing loss, or the other ear has a sensory neural hearing loss. Now we can do the Rinne's test. So, we need to take the tuning fork, place it on Bob's mastoid process, ask him when he can stop hearing it, and then place it next to his ear. Since Bob is saying that the sound was louder when it was on his mastoid process than when it's next to his ear, it means that bone conduction is better than air conduction, meaning there's a conductive hearing loss in this ear. We'd also repeat Rinne's on the other side to check it's normal. If Bob had had a normal Rinne's test, also known as a positive Rinne's test, where the air conduction is better than bone conduction, it would mean that the other ear has a sensory neural hearing loss. Thank you for watching this Medic in a Minute video.